Hello Year 10 and welcome to your Triple Science Extension lesson, okay, with me this week, and we're doing monoclonal antibodies. So this is for everyone in 10A and anyone in my 10 Alpha class that couldn't attend school this week. So what you need to have this lesson is a print of the resources. Now, if you haven't printed them, it's not a problem because everything you need will be in this video. Have a pen and paper if you haven't printed it off, and also no phones. It's a very lovely lesson, but I want your full attention, please. So before we get stuck into the new stuff, I want you to answer these 5 questions for me. So again, pause the video now and have a go at these 5 questions. What can you learn from this topic? So guys, here are your answers to these questions, okay? Again, it's all about infection and response. So it's a little add-on to the topic earlier in this term. So first of all, a pathogen is a microorganism called disease. I'm sure you knew that. The 3 ways white blood cells respond to pathogens is they do phagocytosis, they engulf pathogens, they produce antitoxins and also antibodies. That's the important one here, today's lesson. Now, an antigen is a surface marker on a protein, and an antibody is the complementary protein to unique antigens produced by the white blood cells. And I've asked for a diagram for this, so hopefully make sure you understand. But here's my diagram. I've got 2 pathogens here, the unique antigens around the edge, and an antibody is being produced by the white blood cells, and it's stuck them together. And the reason it's being stuck together is the white blood cell comes along and it engulfs them. It engulfs them and destroys them, and that makes you better. So today we're looking at monoclonal antibodies, and actually what we need to know is new knowledge on the next page. So I've already started the first bit, but here's some new knowledge for you. So first of all, a monoclonal antibody is an antibody. Antibodies that are identical. And if you think about it, mono means one, like monocle, one eye, and clonal means copy. So you've got antibodies that are all identical. Now, when you learn about the immune response, you just knew white blood cells produce antibodies, but it's a special name for them, the ones that do, and they're called B lymphocytes. So that is what produces your antibodies. Now, these cells are not useful for production of antibodies because they can't divide. Once they are made, they are unable to do mitosis to divide. So therefore, you have a limited number of them. But what we know is that tumour cells or cancerous cells are able to reproduce rapidly. So as scientists, we've come up with a solution to this problem. And this is the diagram we're going to look at next. So here is your diagram. Now what I've done is we've got mice. Now mice are used because there's lots of them. Ethically, you could argue that's wrong, but for benefits of humans, we use mice. And what the mice do is they are good at making B lymphocytes. And what we do as humans is we inject the mouse with, for example, a virus or a bacteria that you want to produce antibodies for. Now the mouse will make lots of B lymphocytes. And then what we do is we take some tumour cells and we combine the lymphocytes with the tumour cells to make what we call a hybridoma. It is the combination of B lymphocytes and tumour cells. Now, the reason these are really useful is they are able to divide rapidly. And if you've got more of these cells, this means you produce loads of antibodies. So you are making lots of a particular antibody, which we can use for in lots of reasons we'll look at in a second. Now, again, next question, what is a hybridoma? If we define that, okay, it is the combination of a tumour cell and a B lymphocyte. So you're probably asking me, so what are we learning this for? Why are we caring about this? It is brand new science. And actually, okay, there's 4 main uses in science for these, okay? First of all, we use them for diagnosis. And the particular example you need to know about is pregnancy tests. We also use them for measuring and monitoring, in particular, hormones, okay, and chemicals in the blood. We also use them for research. And finally, we could also potentially use them for treating cancer. Now, why I'm saying that is, what we could do is they could actually stick onto cancer cells. It could be like it could be like a marker so that the drugs could stick the antibodies and kill the cancer cells. And that is why it's really exciting science here. We could be looking forward to in the future. You could even be working on this in the future. So if they're so good, why not use them? It's because they produce major side effects. There was a recent documentary actually I watched, and they were using them, and their side effects were horrendous and actually killed some people. So there's major side effects, and they include things like vomiting. So what I want you to do now is there's quite a lot of information there. I would love you to pause the video for me and just have a go now, quizzing yourself, getting someone in your family to quiz you, and just mentally, what can you remember from memory? So pause the video, what can you remember? Now, the next part of the lesson is actually looking at this example here, and that is explaining how pregnancy tests work. Now, this is the example you need to be able to explain in detail, okay, for your exams next year. Now, the first thing to say is that we need to know about hormone, and this hormone is called HCG. So I'm going to draw it here as a diamond. Now, the only reason we're drawing a diamond just so it's easier image later, but this is called HCG. And the reason we learn about this one is because when a woman is pregnant, their urine contains this hormone, HCG. So whenever a pregnancy test is done, it is testing for the presence of this hormone. Now, pregnancy test, the classic pregnancy test, okay, looks like this. Okay, you've got where you urinate, so you urinate here. And you've got two windows. You've got your test window and you've got your control window. Now, if you remember from the science lesson, the control is done for comparison. So, I'll write it down. So, on the pregnancy tests, there are 3 areas: urination area, test area, and the control area. So we now know that urine contains HCG, and we also know now about what a stick looks like. So we now need to look at what is going on in that test. So the first thing to do is we have got, okay, start with, at the urination area, there are antibodies attached to blue dye. The antibodies are specific to HCG. So what's going on here, okay, is we have our blue dye. So I'm going to do a blue circle here. And coming off it, you have got some antibodies. So again, my diagram looks just like that. So if you've got HCG in your urine, okay, what happens is I'm going to draw again this blue dye with my antibody coming off it. I'm just going to draw 2 this time so we've got more space to write, okay, is the HCG is going to bind to the monoclonal antibodies on the blue dye. So HCG binds to antibodies the dye travels up to the test window by diffusion. So the dye is now traveling up with the antibodies. Now, in the test window, unlike in the urination area, you have got antibodies that are fixed. They cannot move. But the clever thing happens here. You've got your dye with your antibody on it. And the HCG will bind like that onto the fixed antibodies. The blue dye stops moving. So you end up with a collection. I'll do another one here for you. So again, another blue dot there. And again, you've got your HCG. They bind. And that forces a blue dye to appear in the test window, a blue line. And that gives you a positive test. And that tells the person they're pregnant. So in the test area, there are fixed antibodies. If HCG is present, it binds to them and the blue dye shows in the test window. So that's how you get a positive result. You can see that. But surely you're probably going, well, what happens if you're negative? Okay. This time what happens, if we look at the test window again, okay, here are my fixed antibodies. But if you've got no HCG, okay, here's my blue dye with my antibodies attached to it. There's nothing to stop it moving through. There's nothing to stop the blue dye moving through. So it does. So no blue dye is left in the window. So it moves the control area, where in a control area you get a second blue line, which tells you the test is working. So if you are not pregnant, there is no HCG. The blue dye does not stop in the test window. It moves to the control. Okay, so again, it's a lot of information there for you. Okay, I'm going to zoom out so you can see it all now. And again, like before, what I want you to do is just spend a couple of minutes now just embracing this, learning it, testing yourself, getting someone to quiz you on it, whatever works best for you, and then we're going to have a go at a slot. So a couple of minutes, off you go. So to finish on, guys, you've got some exam questions to have a look at. So what I'm going to do is, if you haven't printed this off, I'm going to show it on screen now. If you have got it printed off, you can get onto it straight away. But here's question 1A. Here's question 1B. Here's question 1C. 1D. 1E. And finally, question F. So have a go at the questions and we'll go through the answers when you're finished. So here are the answers, guys, to your questions. So question number 1, 2 precautions you could take stopping a person from getting RSV from spreading it. They can wash their hands or keep a distance. Again, literally what's going on right now, guys. There's loads of it. You can say loads more than that, but that's what I've gone for. Question B, okay, it says, 1 treatment for RSV is monoclonal antibodies, which can be injected into the patient. Scientists can produce them using mice. The first step is to inject the virus into the mouse. Describe the remaining steps. So I've said, the mice's lymphocyte produce antibodies. You get your lymphocytes to combine them with tumor cells. You create a hybridoma, which causes lots of antibodies. So they're your 3 marks there, okay? Question C, describe how increasing a monoclonal antibody, how injecting a monoclonal antibody of RSV helps to treat a patient with suffering disease. The antibody will stick to the virus and the white blood cell will engulf it because it's stuck together, it can't move. Question D, okay, a placebo. Why do placebos? It's so we can compare against and make sure we can control to compare against. The mouse question, okay, what I've done is I've seen that 750 people per group. So I divided it by 100 to get what is 1 person, 7.5. I've then done 7.5 times 4.8, which gives percentage there, which gives me 36, and then 7.5 times 10.4, 78, add them together. So the total number of patients to 114. And the final question, evaluate how well data in the table above supports the conclusion that monoclonal antibodies are more effective at treating RSV than the placebo. Well, guys, it's evaluate, so a pro and a con. My pro is the idea of numbers. Over double the emissions, okay, are with the placebo. However, the negatives I've got is there's no information on the other patients. They could be ill at home. They could be really struggling, but have chosen not to go to the hospital. So that is what I've said there. So guys, that is the end of today's lesson. As always, thank you for listening. It's been a pleasure. If you've got any questions, do message me on here. Otherwise, have a lovely day and I will hopefully see you very soon.